We're going to figure out why some things happen in the blink of an eye, while others, well, they take a lifetime.
I mean, have you ever really stopped to think about this? It's kind of wild. On one hand, you've got dynamite, a reaction so incredibly fast it's just, bam, an explosion. And on the other hand, you have a simple iron nail, slowly, turning to rust over years. They're both just chemical reactions. So what's the deal? Why is one so fast and the other so unbelievably slow?
Well, it turns out there's an entire field of chemistry that's dedicated to answering that exact question. It's all about figuring out chemistry's internal clock, the thing that decides if a reaction is going to be over in a nanosecond or if it's going to take centuries to finish up.
And that field has a name, chemical kinetics. Honestly, the best way to think about it is as the detective work of chemistry. Kinetics doesn't just ask what happens in a reaction, it asks how fast it happens, and more importantly, why it happens at that particular speed.
Okay, so if we're going to be speed detectives, our first job is obvious, right? How in the world do you measure the speed of a chemical reaction? Well, just like a car has a speedometer, chemists have their own ways to clock how fast things are going.
And it's actually pretty logical when you think about it. We can just watch the starting ingredients, what we call the reactants, and see how fast they get all used up. Or we can do the opposite. We can watch the final thing we're making, the products, and measure how quickly they show up. It's kind of like baking a cake, right? You could measure your baking speed by timing how fast the flour and eggs disappear from the bowls, or by timing how fast the actual cake rises in the oven. Same idea.
But, it gets a little more detailed than that. When we talk about speed, are we talking about the whole trip from start to finish? Or a single snapshot in time? In the world of kinetics, the answer is, well, it's both. The absolute best way to get this is to think about a road trip. The average rate is your total trip speed. You drove 300 miles in 5 hours, so your average speed was 60 miles per hour. Simple. But the instantaneous rate, that's what your car's speedometer is showing you at any single moment. You might be going 70 on the highway, then 25 through a small town. Both of those numbers, the average and the instantaneous, tell you a really important part of the story.
All right, now this is where things get really cool, because this is where the power lies. We know we can measure the speed, but can we control it? And the answer is a huge yes. There are basically 4 main control knobs we can turn to make a reaction go faster or slower. And here they are, our 4 key players. First, temperature. That one's pretty intuitive. Then there's the concentration. That's just how much of the starting stuff you have packed into a space. Then surface area. And finally, a really interesting one, a catalyst. A catalyst is like a chemical matchmaker. It doesn't get used up, it just creates an easier, faster path for the reaction to happen. Think of it like a secret tunnel that gets you to your destination way quicker.
And here's the best part. The rule of thumb is incredibly simple. If you increase any of these 4 things, you almost always increase the reaction rate. Want something to happen faster? Turn up the heat, add more stuff, grind it up to increase the surface area, or toss in a catalyst. This right here, this is the secret behind our whole dynamite versus rust mystery.
Let's just zoom in on temperature for a sec. Why does cranking up the heat make things go faster? Well, when you add heat, you're just pumping energy into the molecules. They start zipping and bouncing around like crazy, which means they're going to crash into each other way more often and with a lot more force. And more energetic collisions mean a much faster reaction. It's as simple as that. So, why do we care about any of this? I mean, is this just some abstract science? No way. Understanding and controlling these reaction rates is absolutely fundamental to our modern world, from the food in your kitchen to the medicines that keep us healthy.
Seriously, think about it. Your refrigerator is literally a chemical kinetics machine. Its whole job is to lower the temperature to slow down the reactions that make food go bad. When scientists design a new drug, they have to carefully control how fast it reacts in your body to be effective and safe. And in giant industrial plants, controlling reaction rates is the key to making everything from plastic to fertilizer without things, blowing up. It is everywhere.
This quote just nails it perfectly. The ability to control the speed of chemical change is one of the most powerful tools humanity has ever developed. It's literally the difference between creating a life-saving medicine and creating a devastating explosion. And it all comes down to kinetics.
So I'm going to leave you with a thought. Now that you know the rules, now that you know about these control knobs of chemistry, what everyday reaction would you choose to change? Would you want to speed up how fast a cut heals? Or maybe slow down how fast your favorite t-shirt fades in the wash? The possibilities are endless. Pretty cool to think about, isn't it?